And now let's have the last presentation delivered by Marcin Jasiński from the Silesian University of Technology. It will be about the modeling and optimization of some types of bridges in the BIM environment. So, good afternoon, ladies and gentlemen. Ladies and gentlemen, automation is one of the most commonly discussed aspects requiring implementation of developing in the designing process. And I know it from my own experience and also from scientific studies carried out by habitat studies. And so the need of automatization, they also require facilitation of intersection element development of structure options, detailing, and analysis of structures. To catch the difference between a perfect designing process and automation version, it is good to use the model provided by Oxman, and there is a designer in the center and 4 coordinated elements, and how you develop the documentation, generation of documents, evaluation of variance, and also performance designing. And in this presentation, I will try to replace traditional limited variants of the designing process with so-called integrated model based on automated integration of these aspects. And for this, I will connect 3 elements: BIM methodology, optimization algorithms, and machine learning, and design and programming with IT data collection. And I will also be using one of the major goals. So these are bridges made of compressed concrete. And in this approach, the BIM model will be used for structural optimization of this bridge, and this will play 4 functions. And this will be isolation element and activation cost element and visualization of solutions. And the following steps are taken into account. First of all, we create manually input model with a definition of primary definition and the surrounding. There are defined relationship between all these elements of the bridge and the general semantics of the model, and the changes of the elements will trigger updating of some structure elements. And the model also responds to collisions, and this is the environment of some bill of materials. And in stages, you can catch also the volumes of covered works. And using the parameterization included in the BIM model, we create 30 some numerical variants which are part of these elements. And this general algorithm for optimization, this is a generic algorithm, starts with evaluation of cost for each of 30 solutions, primary solutions. For an individual solution, these are modification of BIM model geometrization with the bill of material, creating of mass model for statical analysis, and compression elements selection using neural grid, and externally applicated. And all this will be also added, or there will be also added reinforcement. After the reinforcement of all the 30 options, there are standard generic algorithms, selections, crossing, and mutation of variance. And as a result, we create a new generation of solutions, which again needs to be evaluated in terms of costs. And in the tool, we generate 50 elements, 30 options each. So we will be analyzing 1,500 solutions. and they will be better and better, step by step. Based on the BIM model, this is a physical model with the application of C# language. We use some lower level models which are for statistical or longitudinal analysis, PE files, together with others, some kind of connected elements, and some intermediary steps are included in the input elements. And they include not only the BIM model, but also those files, and they were ready before we started to evaluation of the tool based on the constitutional analysis. And also the reinforcement still is included in this element. And a very important element of this optimization system is the element of selection of stressed concrete. And this is what I'm going to concentrate on. And an individual, repeatable elements consist of calculation of compression force losses, defining of the compression, implementing it into the mass analysis, statistical analysis, and finally achieving of the border conditions. For compression, there are analyzed 200 strings, so this is 100 sets for only one structure. And this scope will be repeated every time for all 1,500 variants, which brings us to 30 million of calls. And that many number of repetitions requires us to replace this process with a faster generic model with the application of neuronal grid network. It is based on a limited number of mass simulations, allowing us to create a dependency of a string and statistical effects. And from that point, this dependency will be used for fathered repetitions for identical elements as being faster alternative of mass simulation. For example, for this set of strings, we've got those straight ones and curved ones, so each generations are more and more ordered, and more domination of the set with a minimum mass. And this set should also meet the requirements or limitations, geometrical and tensional limitations. And replacing of this mass simulation, which is time-consuming, with the neuronal analysis, allows us to analyze this system from 16 hours to 12 minutes. In the context of selection of geometry, we also select those preliminary data, and this is much dispersed. And with the next generations, there is an increased number of sets and the domination of the optimum solution. This is the 10th generation and the 50th generation. And I also need to mention the limitations which are defined in the software and how they affect the result. These solutions have been used with omitting of, with elimination of the bending of supports, as this would move us towards to other, probably more typical geometry. Nevertheless, this approach allows or responds to automation, the needs of automation of the designing process, but also optimization of the structure. And this tool can be used on the stage of conceptual design, but it is not only limited to that one. And how much detailed the model data is, for reinforcements or compression, this is also useful for execution design. And with BIM, we are able to create to use the files also in other stages of the construction process, in other purposes, like for integration of different aspects where BIM plays an important role. And directly or indirectly, I have answered to 4 major challenges in terms of facilitating of designing process. Thank you very much. Thank you, Marcin.